Hey, what's up guys? In this video we're going to learn how to calculate missing side lengths in right triangles using the ratio called sine. Alright, here it is. Alright guys, the first thing you're going to want to do is identify your hypotenuse. So whenever you have a right triangle, the hypotenuse is always going to be opposite of the right angle. And so in this case, the hypotenuse is going to be this side right here that's 2.2 units long. And then the word adjacent means next to. And so the adjacent side of this particular angle here is going to be this side because it's next to the angle. And then that leaves the opposite side. So the opposite side of the angle is going to be x in this case. And so whenever you have a trig problem like this and the adjacent side isn't involved at all, so you don't know the adjacent side and you also don't want to find the adjacent side. If both of those things are true, then sine's going to be the trig ratio you want to use because sine's the only trig ratio that doesn't involve the adjacent side. And so the sine of a particular angle is defined as the opposite side divided by the hypotenuse. And so if we can write here the sine of 41 degrees, and we can set that equal to its opposite side, which is x in this case, divided by the hypotenuse of the triangle, which is 2.2. Okay, and from here it's just a matter of solving an equation. So we're just trying to get x by itself. And you might be tempted to type this into a calculator first. And you can certainly do that, but what you end up doing is you round when you type this into a calculator, and then we end up doing another operation, and then you end up rounding again, and sometimes you can make multiple sources of rounding error, which we generally want to avoid. And so I'm going to hold off on typing this into a calculator, and I'm just going to worry about getting x by itself. So to get x by itself, all I have to do here is multiply both sides by 2.2 to cancel the denominator. Okay. And this is going to leave me with whatever this is. Again, I'm not going to type that into a calculator yet. I'm just going to leave that as 2.2 times the sine of 41. And then of course my denominator canceled here, so I'm left with x. And so this here is what we call an exact answer, but if you do want to get a better sense for how long this side is, then you would go ahead and type this into a calculator and then round. And if you do that, in this case, you get approximately 1.44. All right. So now there's a similar problem here. Again, this time the right angle is down here. The triangle is just oriented a bit differently, which is fine. The right angle's here, which makes the hypotenuse x. And then again, the adjacent side is the side that's next to the angle, which would be right here, which we don't know. And then the opposite side is where the angle opens up to, so that would be 9.4. So again, the adjacent side here plays no role in this. We don't know it, and we also don't want to find it. So we're not interested in it at all, and when that's the case, sine is the way to go here. So I'm going to set it up the same way. I'll do the sine of 72, since this is the angle that I have. And again, I can set that equal to the opposite, which in this case is 9.4. over the hypotenuse, which is x in this case. And now this looks a little bit different than the last one because now x is in the denominator, right? Last time it was the opposite side that we didn't know. So we had x in the numerator, but this time it's the hypotenuse that we don't know. And so the denominator is what we're looking for. So this complicates things a little bit because, again, my goal is to get x by itself. So I can't just simply multiply both sides by 9.4 to cancel the 9.4 like I would in the last example. So what I'm going to do is I'm going to try to get x out from underneath this denominator. And so to do that, I'm going to multiply both sides by x. Because what this is going to do is it's going to cancel it from the denominator, which is nice, and then it'll sort of end up showing up on the left, which is good. Okay, so here again, I'm not going to type this into a calculator because I don't want to round too many times. So I have just x times sine of 72, and that's going to equal 9.4 because my x's are going to cancel. All right, and now if I'm trying to solve for x, then I need to divide both sides by the sine of 72. And what that does is it's going to cancel my sine ratio there. And then this will finally leave me with x equals this. Again, this is an exact answer, but if you are tasked with rounding to a certain decimal, or if you want to get a better sense for how long this is, because it's kind of difficult to tell how long this is with that expression, you can type that into a calculator and you will get approximately 9.88. All right, and with that said, guys, it's been demonstrated.